All right, let's try to talk through this problem. So my intention of this problem was so we have this equation, we have a sine curve, cosine curve, we have a point of intersection, and the student has guessed that this point of intersection, let me get a different color, is 9.2. And so the question is, are they close enough? Are they within 2%? The way that I didn't think about this, but it actually seems like a valid way to think about the problem is, if you took that value of 9.2 and plugged it in for x, how close are you to 3? Are you within 2%? That wasn't my intention. This is what I was trying to get at. If you take the equation, all right, 3 plus equals 2 plus 2 cosine x minus 2. I want to solve this for x. I want to find my algebraic solution. And I'm going to have to use an arc cosine to do that, because if I just use cosine inverse, I'm only going to get one answer, and I don't know that that's that point of intersection I'm looking at. So we go through this, we solve it the way we normally would. Minus 2, minus 2. 1 is 2 cosine x minus 2. I'm going to divide by 2. And so I get 0.5 equals cosine x minus 2. And now, since I'm interested in all the solutions, I'm going to use arc cosine. So I have arc cosine 0.5 equals arc cosine of cosine x minus 2. And that huge mess on the right-hand side, what does that reduce to? X minus 2. Because they're inverse operations, that's why we did it. So I'm left with x minus 2. And arc cosine is defined as plus or minus cosine inverse 0.5 plus 2 pi n. And n is an integer. So all that's doing is it's giving me, if I think about my circle, so if I had a circle, I have my coordinates, that's a bad coordinate, and I had an angle here of theta, this is minus theta, and the 2 pi is just giving me rotations around the circle. So that's all that expression is telling me. So I come and I want to solve it. And so I get x equals plus or minus cosine inverse 0.5 plus 2 pi n plus 2. That is the solution to all of them. But I want one of them. How do I find the one that I'm looking for?
Spreadsheet.
I could put in a spreadsheet. And what am I going to do with my spreadsheet? What values do I need to change on this side to get numbers out? N. So I pick a number for n, I plug it in, and I see if I get my 9 point, something around 9.3. 9.2, I forget what the guess was. I'm going to use an educated guess here, because I saw first period do it. And I'm going to say the positive cosine inverse, 0.5, plus 2 pi. So I'm going to let n equal 1 plus 2. I plug that in my calculator, make sure I'm in radian mode. And I get x equals 9.33. So I got a value. What was the guess?
9.2.
9.2. So the question is,
Pretty damn close.
pretty close. Is it within 2%?
Yes.
Yeah. If I do 9.33 minus 9.2 over 9.33, I get, somebody help me out here, 9.33 minus 9.2. 0.0139. What's that as a percent?
1%.
1.39%. So really close. So the graphical method is great because it's quick. It gets us approximate solutions. The algebraic is exact. Yes, sir.
So if you do